here first one is coplanar forces. Consider here we are having this plane, and the forces acting in this plane, plane, and it is P1, P2 and P3. The line of action and the definition of coplanar forces is the forces whose lines of action are passing through one single plane is known as same plane. The forces whose lines of action are passing through a same plane known as coplanar forces. So here P1, P2, the line of action of this P1, P2 and P3 are passing through a single one plane, and so they are said they are coplanar forces. If the line of action of forces do not pass from a lie on the same plane, known as non-coplanar forces. Here we can see this P3, the line of action of P3 and P4 do not lie on the same plane. So P3 and P4 are non-coplanar forces. But see, this P4 and P1, the line of action of P4 and P1 passing through one point, so we can say P1 and P4 are coplanar, but P3 and P1 are non-coplanar forces. For the analysis of any force system, first we need to identify the plane. Okay, now here we can see the concurrent force system. The forces whose lines of action are passing through a one single point, known as concurrent force system. See, remember the action the action will produce only in this kind of force system. Motion will produce only in this kind of force system. Here the force line of action of this point force P1 passing through this point, line of action of this force P2 also passing through this point, and line of action of this P3 passing through this point. And so P1, P2 and P3 and P4 are the concurrent, they are forming the concurrent force system. Okay, here we are having the good example of concurrent force system is this giant wheel. So the forces exerted, the line of action of these forces, and this force and this force will passing through this point. So we can say the giant wheel is a system, a concurrent force system, and concurrent force system will produce only translatory motion. In case of concurrent force system, translatory motion will produce. Non-concurrent force system, the forces whose lines of action do not pass from a single point, known as non-coplanar concurrent force system. Here we can see this string is under tension, also this string is under tension, and also this string is under tension due to the force of 100 Newton force at this point and 100 Newton force at this point, and they are exerting the force at different point, and the line of action of this 100 Newton force is passing through this point, and line of action of this force is passing through this point. So we can say the 100 Newton and 200 Newton is a non-concurrent force system. Here also we are having one another example. The line of action of force, this force is passing through this point, here passing through this point, first 1, 3 and 4. So all the line of action of forces are passing through a different point, so we can say this system is a non-concurrent force system. Another one, also we can combine the force system like coplanar forces and concurrent forces. If we can say coplanar and coplanar and concurrent force system, if the forces whose lines of action are lie on the same plane, but the forces whose lines of action also meet at one point, known as coplanar concurrent force system. We can combine the force system like this. We can here we are having a collinear forces. The forces whose lines of action are passing through a single same line, known as collinear forces. Here we can see P2, we are having a force P2, P3, P4 and P5. The line of action lie on the same, all these forces lie on the same line, so it is, we can say this is the collinear forces. The good example of this collinear forces is we always play the game tug of war. So force exerted by the two team in opposite direction. So but the line of action passing through a same line, so we can say it is a collinear forces. Okay, but here we can combine collinear and coplanar forces. Okay, if the line of action of P1 and P2 passing through a same line and they lie on the same plane, then we can say it is a coplanar collinear forces. Okay, now parallel forces. The forces whose lines of action are parallel to each other, known as parallel forces. The non-concurrent forces are also one kind of parallel forces. It may be horizontal, it may be vertical, but here the forces lines of action of all these forces are parallel to each other, so we can say it is a parallel force system. The parallel force system and concurrent force system, we can also say parallel force system as a non-concurrent force system. Parallel force system can produce the translatory as well as rotational motion. So in case of parallel force system, we are having two translatory as well as rotational motion. Okay, this non-coplanar, and we can combine the non-coplanar as well as non-concurrent force system. If the lines of action of forces do not lie on the same plane, as well as the lines of action are not passing through a same point, known as non-coplanar non-concurrent force system. So this is the combination of non-coplanar and non-concurrent force system. Okay, in case of unlike parallel forces, the forces whose lines of action are lines of action are parallel to each other, but they are acting in opposite direction. This is known as unlike parallel forces. And if the lines of action of forces do not passing through are parallel to each other but acting in the same direction, known as like parallel forces. So here this is the types of force system. Okay, so let us revise all the topics. First we need to understand the concept of force, why force is necessary need to understand in mechanics. Mechanics, the entire mechanics is based on application of force, so we need to understand the force. And also so the definition of force is, it is an agent which produce or tends to produce motion of the body. So if the body goes from rest to motion, causes of force. If we can say it is an agent which destroy or tends to destroy motion of a body. So if the body goes from the state of motion to the state of rest due to the force, so it is a force. And the unit of force is in SI force, in SI system it is Newton, in MKS unit kgf, kg per meter square, in CGS system gram centimeter per second square. And characteristics of the force, it has a magnitude, it has a direction, it has a nature, it has a point of application, it has a line of action. Without proper understanding of characteristics of the force, it is quite difficult to calculate, to do the numerical of mechanics of solids. So it has a magnitude. Since a force is vector quantity, so we can express it in a 10 kilonewton, 20 kilonewton. It has a direction. Direction may be represented by direction of the force may be represented by a sense of this force. So it may be go from this north x axis or angle with reference axis. Nature of force, the force has two kind of nature, pull and push. Force has also point of application. The point at which we can apply the force is known as point of application. Line of action of force, here it is an infinite line passing through point of application of a point of application is known as line of action of force. We can see the graphical representation of force here. A and B is a line of action. 10 kilonewton is a magnitude of force, and this angle with reference axis is known as direction. So this force will go from this in this line because it is having a line of action in this direction. Types of forces: surface forces. This kind of forces require physical contact and or direct contact of one body exerting force on another body. Body force: if the force is exerted by one body on another body without physical contact, are known as body forces. And they are gravitational force, magnetic force, and electric force. Gravitational force, the force exerted by the earth on a body, it is known as gravitational force. So this kind of gravitational force will act like this. Remember here, the body gravitational force do not require any medium, and it always act vertically downward. In case here, magnetic force developed between two magnetically charged body are called magnetic force. Electric force developed between two electrically charged body are called electrical force. Point force, the force exerting over a small area compared to dimensions of the object. So here the object is having more area as compared to this point load, and we can say the force concentrated at one point is also known as point load. The force distributed over certain length known as distributed forces. And here we can see this force is distributed over this span, so we can say it is a distributed force. External force and internal force. The force exerted by a weight of block A on block B is external force on block B. So this force, the force exerted by block A on block B is known as external force, and this block B will resist this external force is known as internal force. And internal force, the body applied the internal force to resist the deformation. Action and reaction. Likewise, Newton's third law, whenever body exert a force, we can say it is action on the body, and the other body exert similar force, so on the former body, known as reaction. Here we can see this block A exerting the force on block B. So block B is opposing this the force exerted by block A. So the force exerted by block A is known as action, and the force exerted by block B is known as reaction. Here frictional force, when body slide on a surface on which it is resting, opposing the motion is produced at the contact surface. This resisting force is called friction. Here see, we are applying the force on this body with magnitude of force P, but at the contacting surface this motion will resist, and this resistance force is known as frictional force. Force of buoyancy, when a body immersed on a fluid, there is a tendency of fluid to exert an upward force on the submerged body. This upward force is known as force of buoyancy. So every object float on another on a fluid due to this force of buoyancy. Here we can see the animation. Cohesion and adhesion. Cohesion means it is the force developed between molecules of same material. Here the force developed between the this liquid in the bottle is known as cohesion, and the force developed between liquid and this solid surface is known as adhesion. Okay. If we exert a force on a body and it is a single force, we can say it is a compressive force or a tensile force. But if we